It's a pleasure to be a part of this August gathering and also key respondents from 3D technology. 3D Graphy has been consciously looking at democratizing 3D technology in the country. We have our own platform and how 3D technology can do a great value for different sectors across industries is something which we will also probably want to discuss on a platform like this. And I'm fortunate enough to have this line of speakers who are experts in 3D technology. And today when I see the prospect of being a part of Business World Initiative, the BW Disrupt, this is exactly very tuned in terms of what we do as a technology which is disrupting the market. So today we'll also talk about how 3D technology is at a time when it's in due course going to be a game changer for the technology. So may I now like to ask the first question from somebody who is already the end user using the technology, Mr. Bibudatta Mohanty. Mr. Bibu is also from Vedanta, a key responder using the technology and 3D printing in a way in terms of being efficient for the organization in a way. So your take on this in terms of decentralization of this technology and how it is actually benefiting the course.
Good morning, everybody. I'm Bibudatta Mohanty. I'm the head of innovation for aluminium sector of Vedanta Aluminium. As we all must be knowing, Vedanta is the highest producer of aluminium in the world. We have got the world's biggest smelter outside China at a single location of around 1.8 million ton capacity of aluminium production and 3600 megawatt power generation. Coming to the topic of 3D printing or additive manufacturing, what I can say, this has, as Vedanta has taken up this technological intervention at a time when the world was closed, like initiation of the COVID time. So it is such a technology, unless and until we go use it and deep dive into it, we cannot know about the prospects, how a metal and mining sector or a heavy industry is getting something out of 3D printing. It's normally we think that 3D printing is a designer's baby and a designing company or anybody who makes prototypes. Yes, we have taken up this technology as a technological intervention at a time when the world was closed. It has given us many advantages, like what can you say, supply chain challenges was there. We are not getting many spares, many equipments were down because of those shutdown issues. So at that time, this especially I will take the name of the Markforged printer, the carbon fiber one, has helped us a lot because this material can be easily changed with our metal part also. So we have many such business cases, or you can say success stories, wherein a single intervention has helped us to get a equipment up, which was scheduled to be up after 30 days or 40 days when we get the spares imported from, say, Europe or American countries, or in fact Chinese countries also, which was totally closed down. So this technology has really helped us, and we are in the verge of means what you say, our innovation centers are there, wherein these printers and scanners are placed, and every day new ideas are coming up, new challenges are coming up. People have even started developing things, internal parts with this technology. So I'll say that there are many prospects in, not in industry like us, but in every area. And the line behind it, unless and until we use it, we cannot know the advantages of it. Thank you.
So one more question to you, actually, as a manufacturer of these high-end, as somebody who is actually offering solutions in terms of also manufacturing on the kind of quantums that you actually do. There are times of downtime. So how do you see that 3D printing can address this particular area of a challenge?
Sorry, I could not get it. Could you please?
Downtime in terms of the manufacturing units.
Okay, equipment downtime. Yeah. See, we have got, we all know that normally the technology or the engineering solutions we get from German countries, Europe's other parts of Europe, America, or in fact China also. Ours is a plant which is mostly a Chinese technology. Most of the equipments are OEM are Chinese countries. So when the spare this equipment goes down, yes, we maintain a lot of inventory, lot of spares. But see, the maintenance person also I can tell, because I had a prior experience of heading the maintenance cell of the smelter. So there are many internal parts, small things which cannot be procured at the right time, and the machine could be up. If you just take one success story, I want to share with you people over here. We have the XRD machines. They are for the metal purity testing. So when this XRF machine was down, it was almost like I cannot predict the purity of the metal, and each electrolytic cell has a different purity, and we produce based on the purity, what type of it is, a P1020 or a P0608, what are the different export grade primary aluminum products we export out. But the purity need to be taken care of. At that time, when this machine was down, it was a real challenge, because such a huge capacity, we cannot go for manual sampling of the metal. At that this it was just I will tell the one of the first project of my 3D printer, wherein we took up and we developed some of the internal o-rings and some of the internal parts with the help of this carbon fiber one. It was changed hands-on, and the machine was up in, I think, around 8 to 10 hours. So if you can compare it, the downtime could have gone to 45 days, because the OEM was from Poland.
Now, when I also understand that you've been a user of a technology from a company named Markforged. So I have the privilege also to have Anuj here. So Anuj, what was your first interaction? Did you actually understand the challenges and then probably want to actually offer the solution? That's the standard process to follow. So how do you see that that connect did happen, and what do you see the prospect of 3D technology in a country like us?
It's a great platform where we are seeing Mr. Mohanty as well as one of the, I would say, the first organization to adopt this technology to overcome the supply chain challenges. So each and every industry verticals or industry domain does have their own challenges, but this challenge is definitely one of the most critical one. Having huge land of metal and mining plant where you have hundreds of equipment and anything can go wrong with any of the equipment. So a lot of planning needs to be done. So coming to your question, Shibu, yes, there were a lot of interactions, discussions, which we did with Vedanta team. Mr. Mohanty was spearheading that discussion. So the first thing which we need to understand was, yes, there are supply chain issues. And definitely post-COVID, each and every organization does understand that either you have to maintain those kind of huge inventories, or you have to be ready for that downtime, which no industry can be ready for the downtime. Everybody has to plan that, okay, there's no downtime in the machines as well. So when we are talking about implementing a 3D printing solution with such a, I would say, these are the plants which are in remote places, the equipments are very, very heavy. The first question came into everybody's mind, can 3D printer or 3D printed part handle these kind of harsh environment, or these kind of metal parts also which are there in those kind of machines? So do we have a solution for that? Can it really support those kind of challenges? So then we went through the complete BOQ. So I think it was a great effort from Vedanta team also. As a technology, this is still an emerging technology. People are still trying to adopt it, trying to learn, trying to understand the technology in much and more in detailed manner, where the material science is also, metallurgy is also involved. Now, each and every industry needs to take some step ahead to understand that everything cannot be put on the paper in terms of ROI. So it is an innovation tool as well as a tool which is the future for Industry 4.0, which is the future for digital manufacturing. So the whole idea was, let's look into some of the non-critical part which can be implemented in the first phase of the implementing this technology. Rather than looking into the bigger problems, let's start small. That's what Vedanta has done. That's what when we joined had with them. So the whole idea was to look into an area where definitely it is going to help us in replacing some of the parts which can easily be printed by a carbon fiber based printer. Maybe some polymer parts can be easily replaced, and gradually with the help of the innovation team and Mr. Mohanty's leadership in terms of driving this adoption into the plant, now they are able to replace some of the parts which are in metal, and it has already been replaced by the carbon fiber based 3D printed part as well. So I would say the whole idea is, let's look into this technology about handling these supply chain issues where the lead times are very high. Can it be solving the bigger problem or supply chain? Can it solve the problem of maybe reducing the carbon footprint? Why we're saying that reducing the carbon footprint as well, or environment, health and safety issues as well? So this is a technology which can be handled remotely also. We call it as a distributed manufacturing. There are a lot of global companies, companies like Vestas, where they have some 20 plus plant in wind energy. They have already started putting in place all the printers across different plants, and they are controlling it from the central point where they are printing those parts directly at the plant. Rather than flying those parts from one country to another country, they are printing those parts directly at the point of need. So we call this technology as a movement towards digital manufacturing, or printing the parts at the point of need, rather than looking into something which is definitely supply chain. Everybody knows that it's a big challenge during the COVID times when the country's borders were sealed. That was the same time when Vedanta came into in discussion with us as well, that we need to look into some technology which gradually will help us to create the digital inventory as well. It may not be to all the BOQ of maybe 50,000 or 1 million part. It could be for maybe 10% of those parts which are still critical, which are still holding our operations, which are still troubling our production cycles as well. And the other benefit of doing this digitalization or printing the parts at the point of need is, now we are reverse engineering those parts and printing it. So can we look into improving the design? Can we look into reducing the weight of the part? Can we look into improving the efficiencies of the equipment as well? So there are a lot of I would say benefit which comes along handling those firefighting issues as well.
Thank you, Anuj. Very well said in terms of where all this technology can be of great help in terms of making it more coefficient in terms of efficiency. Now, while you spoke about, the time that we all gone through, the COVID times, it was a challenging time. And at that time to manufacture and have it localized and manufacture it localized was always a challenge for a conventional method of manufacturing. And that is the time where 3D printing was a life-saving, even in the medical space. We all know and we've all heard about ventilators which were manufactured and customized, which was a possibility. Now, we also see the larger scope. See, what we understand is when we actually get into a challenging time, that is where we try to look at solutions. And that's where technology gets more prominence. And there is the course for us to head and build on that. And that's the time that we've all gone through in the COVID times. Supply chain has been really suffering and the processes were very tough. But now that I also understand, when Anuj also mentioned about Fastech, is that the company, Anuj, that you mentioned in terms of making an integrated process of supply chain process. Yeah, spoke. Yeah. So may I know from you, Jagannath, somebody who is actually in the manufacturing space. Jagannath is the CEO for BFW and also M2 Next. They've been manufacturing CNC machines, in building these molds, and now also into additive manufacturing, indigenously manufacturing these machines here in the country, thanks for Atmanirbhar Bharat. So Jagannath, how do you think that this space can be really ventured into when it comes to a digital manufacturing space, ensuring that parts can be manufactured and can be offered in terms of faster, in terms of execution, and also creating an opportunity for more businesses coming in this space?
Been into additive manufacturing since a year. So the very relevant question what you've asked, in fact, there is a platform on a traditional subtractive manufacturing where there is a global connect between the manufacturer and the user. So if we look at the technology, very similar to this, a part can be manufactured and flown in 24 hours because the machine is elsewhere and the user is elsewhere, where there is a complete tie-up of the freight forwarder, the user, and the manufacturer. Now, the power of digitalization here, or the digitization, is the part is presented in a CAM form in a hosted website. And the rights are given for access for potential users all over the world. And they get a message on their device to say that there is a part requirement which can be manufactured either in 24 hours or 72 hours or a week's time. And the price and the entire contour is already fixed and available, and you get an access to look at the part. You just need to accept. The moment you accept the part that you will manufacture, within 24 hours, the FedEx or the DHL will come to your site and collect the part. That's how has been the kind of business what we are seeing in subtractive traditional manufacturing. But one step beyond this for 3D printing would be that the distributed manufacturing, where you have potential equipment sitting very close to the user place. You could probably have a designer sitting somewhere who could use DFAM and produce the STL file of the part and then push it to the platform where the user will get an access for that, build the part who is closest to the required place, and the part can be flown from that point or could be sent by the road. So the difference what we are seeing in potentially is you could have the the builder, the 3D printer very closest to you, and you could also have the expertise globally sitting somewhere in another corner of the world who could do a DFAM and then post the STL file to the nearest 3D printer. So this is something which a connect we are foreseeing. So as a result, if you see the entire carbon emission is minimized because you are only moving the part from the closest location to the user location, number one. Number two is the developer who is sitting somewhere and doing this design is almost in real time, you get the access for the part, what is already designed and available for print. Number three is the printer, which is sitting locally in the area that which is going to print, could definitely be a shop floor kind of a thing, which is very simple to use, wherein the OEE of this equipment could be really very high. So this is something which I foresee that is going to happen very soon. It's already happening. It's going to happen very soon in bigger picture.
Thank you so much, Jagannath. Now, when you talk about an integrated kind of a setup in terms of digital manufacturing, ladies and gentlemen, what I also understand, technologies do also assist and facilitate. So here is also Vishwajeet, who also works with Ansys as a technology expert. Vishwajeet, now when we talk about Ansys as a software simulation company, here is also something that we are trying to see, ensuring that how wastages can be reduced, ensuring that the parts can be consolidated in terms of size, scale, pricing, all of that put together. How does this software solution help in terms of the process of manufacturing?
So here we are talking about 3D printing solutions, and we see for last 5-10 years lot of discussions on additive manufacturing, and we are trying to explore as much. But why we are shifting towards additive, as Anuj has also shared that this needs a lot of R&D, lot of innovation is going on. But why should we rely on this technology? First thing that we should get benefit against what traditional manufacturing process is, right? So one major benefit what we are talking about, it can be quite quick. That is fine. But same time, where we are also talking about making our carbon footprint lesser and lesser, almost zero carbon footprint. How we can ensure this goals? So first major challenge is with traditional manufacturing, yes, we are having a lot of wastage. Can we reduce this wastage? Where this AM technology give option to us. This is almost having negligible or zero material defect, right? Because here we are not scrapping or just removing material. But same time, major challenge, even though if AM technology is there, if I have to design any product, if I have to go with this product, it is very difficult to just go bluntly and design this product. Maybe I can develop my 3D model and I can go with 3D printing. But when I just start making this bottle, I may get a lot of defect in that. What defect can be? There can be some distortion, there can be some kind of warping or some bending. And just to ensure that there are some kind of supports and some support I have to exactly figure out. Usually it doesn't, work out in one go when I go with, additive technology for any production. So you need certain, validations, you need certain kind of information. Okay, what will be best way to exactly manufacture it with all minimal or, supports that we need to assign so that it should have less, defect in terms of distortions or any kind of, warping in this product. So where software simulation technology helps a lot, it gives, all virtual validation before going to production. You can test it on virtual environment. You can test it each and every instances first on software, and then you can see, okay, now this final product is coming out without much, distortion or almost no distortion. And then you can say, okay, with all these support, these conditions, now I can go for, real manufacturing. So yes, additive manufacturing is, next generation technology, but it is very difficult to go standalone with, this technology. You have to involve a lot of, other research and mindset, like, kind of, simulation technology to make it more successful.
You're right, Vishwajeet. I think 3D printing is one technology in the whole of the basket that we have in the manufacturing space. And what I understand is these are two sides of the same coin. When we have CNC and vacuum casting and various other processes, the shop floor would need a 3D printer, making it more convenient and efficient. Because when it comes to customized manufacturing, 3D printing has a great prospect. Now, we also understand that this technology has really been a game changer in certain industries and sectors. More so when I count on my fingers, aerospace is one sector because you're not looking at mass manufacturing here. And also medical, where you can now print, pre-op requirements for doctors to plan their surgery, to have these models printed, to actually plan their surgery well in advance to make life more, life-saving process. Because in a procedure, you cut open, you're cutting the body, there's profuse blood flowing in. So life is in the blood. So these are sectors and a specialization that this technology has gained a lot of traction. But I also know for the fact that various other sectors and industries that this technology has been very, very prominently used when it comes to, shipbuilding. You have technologies like DED, where Mr. Jagannath is also a key respondent in terms of offering those solutions. But let me now ask Mr. Saroop, who is one of the key respondents from both the sides of his sides of his areas of specialization, but in terms of offering these solutions and also being a digital manufacturing hub in Delhi, in your same town and city. Saroop, how has this technology evolved, and as a service provider in the space, how has it really helped in a way? Because I know that you're very, very focusedly working on 3D technology. That's the service center of excellence that you have been able to build here. Please, thank you so much.
First, I would like to touch upon how many of you know 3D printing? Okay. Anything about 3D printing in terms of what it does, how does it change the world, right? And why it is being talked about as a big disruptor of manufacturing world. Okay. Typically, you would see very big factories of Escort or for big factories of there would be thousands of machines which would be kept for cutting the part from a block of material. In 3D printing, globally, it has been changed. What has been done is that you make a powder or a wire, and without a tool, you start melting it and start printing it out layer by layer to give any geometry. Therefore, it becomes toolless manufacturing. And you don't need factories which are miles together. You are able to create which is this small, okay, in couple of thousand square feet. So with that innovation and with that change, all of us are now looking at it. Can we take it to the place where the parts are needed? Can we manufacture small quantities of parts as and when necessary? So there in the COVID period, when the whole supply chain was disrupted, a healthcare company came to us and said that we want to make 5,000 ventilators. And each of the ventilator required about 380 different type of parts. Okay. Our production center in Delhi, which is only this big, right, could turn around those 380 different parts in 24 days, 1 lakh parts to be delivered to the customer for assembly of the ventilators, which became the lifeline during the COVID period. That is a disruption, and that's a supply chain which one can look at it. How many of you would have come across an accident where your back mirror has gone, right, of the car? Invariably in Delhi and Bombay, you would have everyone suffered the same thing. Now, how long does it take to get that mirror in a workshop of the manufacturer? I would say minimum 15 days, right? Not less than that. Using a tool like 3D printing, I can scan, or if I have a digital inventory, or if the manufacturer had the digital inventory, which means it had a CAD model, I could produce it in a day's time, even if the model was a 20-year-old model, right? Now, that becomes supply chain in terms of maintenance of the equipment which is existing, whether it is in the plant or it is in the consumer good. There was a young entrepreneur which came to us, and he started talking about designing a mixie and launching a mixie. Now, mixie is 30–40% parts which are bought out parts. They are not made. Motors are not made by the startup company. He came to us and said that I want to launch this product, but it is costing me about 50 lakh because he had to make about 7 dies. And how do I launch this product? I don't have that type of money. Now, if he goes with one model in an exhibition, you would appreciate the credibility of this entrepreneur would be very low, right? When we looked at the whole thing, we said we'll give you 5 different variants of the mixie under 11 lakh rupees. And we will give it to you on the 12th day, right? On the 12th day, he had 5 variants of the mixie launched in an exhibition. He could try it out, he could vary it, he could create the colors and could put it in the exhibition and get the market feedback as to which is the mixie which he want to launch. Now, 3D printing, because it's toolless and because it is easy to manufacture, and it can be done in the same machine can be used for printing a consumer good. The same machine can be used for making parts. The same machine is being used for making the drone parts. The same machine is being used for biomedical applications. So I just wanted to give a perspective, Dr. John, is that today 3D printing has not been adopted in India so much, but companies which are making electronic products, companies which are making parts which are very light or want to make lighter part to make it energy efficient, or companies which are into the startup operation, or companies which want to create spare parts, they would find 3D printing very, very useful. And it can be experimented very easily. You don't need very big factories. The operation does not require multiple skills. It requires few skills of the FEA, of the CAD modeling, and then the manufacturing, right? Thanks, that's it.
Thank you so much, Mr. Saroop. Also, it was interesting to have inputs coming from all the experts, from technology experts and also the end users. We also see a lot of opportunities in terms of building this channel to have an opportunity to create more 3D hubs in the country. So 3D Graphy is actively in the process of doing that. Having said that, we've all done many of them for the first time would have in your and understand in terms of responding. We have say what 4 minutes, Uday, for Q&A. Yeah. So if there is any question, and ladies and gentlemen, please, we will be able to address.
My name is Amrendra Kumar. I'm representing Roadcast. Just a small question: how 3D printing is going to be beneficial for mass production? And second is from plastic material to the metallic kind of segment.
Your question is specific to somebody or nobody? Anybody can answer.
Yeah, it's a
So yeah, so mass production is the conventional method now that we see with CNC, where you make a mold, or it is also done through injection molding, and you have lakhs of parts made with one mold. But we are in the time where we are also looking at mass customization. So when we talk about dental, every denture needs a different. Every anatomy of a jaw will be different. So here is a process where the conventional method will not be able to, get the result, is where 3D printing can do the result. So mass customization, where you have a bed where you can have multiple 3D printed parts of these dentures made possible, which otherwise today we do this through milling machine. So one denture, and if there are members of the family who would probably had to go for a buy of a denture, it takes 10 days or 15 days for them to supply. But here is a time that you are now looking at digital manufacturing setups, even in dental labs, and also now even dentists are looking at that kind of a solution. So similarly, there are mass customization as a process can also be a great prospect in having different sizable parts, which is a possibility. If I have to ask Saroop to, Mr. Saroop, please.
Okay, I think you asked about the large production sizes, right? Today, 3D printing is being used. I'll just give you an example of a company which is making close to about 10,000 drones in India. Okay, each of the drone has about 80 parts which have to be manufactured. Today, the drone company get all their parts manufactured by 3D printing. Now, I'm not talking of a lack of parts. I'm talking of 10,000 parts with 3 to 4, which means about 30 to 40,000 parts being manufactured. Now, why is he getting it manufactured? He's getting it manufactured because he wants it lightweight, because he wants to integrate many of the parts so that the reliability can be improved. See, if we have a technology, you have a mobile phone in your hand. Are you using the same way as the phone which is at your home or in the office? You have found a new use and a new application which is enabling you to work more efficiently. 3D printing is a technology which is giving you a breakthrough where multiple parts which are conventionally manufactured as separate parts and then integrated into an assembly can now be actually manufactured as a single part which can be used by you and thereby improve the reliability. Do you know that the LEAP engine of the aircraft, right, which Boeing started with, today is only made by 3D printing because the total number of parts which were there in the LEAP engine were 108 parts. They have been reduced to 13 parts. Now, when they've been reduced to 13 parts, imagine that you don't have the rubber seals, you don't have the nuts, you don't have anything, and the flow of the gases as well as the fuel is so efficient that it has improved the efficiency of the LEAP engine and has reduced the weight and has increased the reliability of your LEAP engine. Now, therefore, 3D printing is being used today for mass production. The second use of the 3D printing in mass production is that I will just like to quote an example, Pepsi, which used to make the PET bottles to fill the Pepsi, right, were being done in metal for doing the blow molding. Today, they only make, and it used to take nearly a month and a half to make a new model of the Pepsi. Today, they make it in 3D printing the mold itself, And with that mold, they are able to produce more than 5 lakh pieces doing the blow molding. Okay? So use the technology where it is best usable. If you say that, can I make my car parts which are in 1 million as an individual part, right? It would be inefficient use because you're using the same conventional method to convert to the new method. Why? Maybe can I integrate parts? Maybe can I make them lighter? Maybe can I make it in a better design? If the time permits, can I take one example? Okay. There was an LED manufacturer which came to us. Now, this LED manufacturer had aluminum extrusion. Okay. 2 extrusions used to join together. He used to put the paper as an insulator and then used to mount the PCB in that, and then used to put the LED light. The conventional weight was 54 grams. When we did the same job in the 3D printing in plastic, our weight got reduced to 24 grams. The cost was still higher. It was at 1200 rupees versus the 600 rupees which he was paying. We converted it into lattice structure, and by doing it conversion into lattice structure, which is creating the holes, we improved his design in 3 ways, which I'll touch upon. And as a result, my weight came down to 9 grams and the cost came down to 400 grams. He got, his inventory was 0 because he didn't have to hold the inventory. He could get it done every month, 200 pieces, 500 pieces, which he needed it. But his improvement in design was that there was a single component of the LED. There was no need of paper insulation because plastic was insulating. And third, it was giving air because I had created the holes, which I would have never done it because the CNC machine cost is much higher. Now, when I did that, automatically my weight got reduced, my material cost got reduced, my manufacturing cost got reduced, and today he gets about 10,000 pieces manufactured by now. Okay, so I think we need to look at it from a different glasses and be able to produce the parts using a new technology. And some parts will be very efficient, some parts will not be very efficient.
Thank you so much, Mr. Saroop. So I think this technology has greats to offer, and I'm sure you got your questions answered in a way. Yeah.
Yeah.
So I think, yeah, so thank you so much, ladies and gentlemen, and thank you so much, panel, for sharing your insights on the subject. And anybody, if you have any questions, you can actually be in touch with around for you to get your answers or queries corrected or you addressed. Thank you so much, and it was a pleasure.